Hey guys, so today you're going to be learning about mid-segments of a triangle. After you watch this video and complete the notes on page 21 through 22, which are just short, brief notes, you will then go and work out the problems on pages 22 through 25. So let's go ahead and get started so you can get to those problems and hopefully have no homework over the weekend. All right, so what is a mid-segment of a triangle? Well, a mid-segment of a triangle, it is a segment whose endpoints are midpoints of two sides of a triangle. So if we look at this triangle to the right, we have this lovely triangle ABC. There's a segment that connects the midpoint of AB, which in this case is M. Remember, those tick marks mean that they are congruent. And then the midpoint of the line segment AC, which is S. This segment right here, MS, is the midsegment of a triangle. Okay, and this midsegment has some special properties. Okay. All right, guys, before we move on to the actual midsegment theorem, which your problems are going to be based on, I want you to look at our triangle up here, ABC. If you see the triangle AMS, we can actually use the side angle side similarity postulate to show that AMS is a similar triangle to triangle ABC. So let's write that down a minute. So AMS triangle is similar to triangle ABC. All right. So, and another reason for why that is true is AMS is simply just a dilation of a magnitude of 1/2. Okay, so think back to our dilations. Yes, I know it was a long time ago. If you were to flip back to your Unit 1 material and look at the dilations, we had a special property where if we have BC, if that line does not pass through the center of the dilation, and in this case our center of dilation is A. Think back, I'll give you a minute to think about that. And what conclusion can you make about BC and MS? Well, what you can conclude is that BC, line segment BC, must be parallel to line segment MS. As long as it does not pass through the center of dilation, it will be parallel. All right, so let's move on and let's get to the good stuff, the mid-segment theorem. Okay, so a mid-segment theorem is in a triangle, the segment joining the midpoints of two sides of a triangle has a length that is half the length of the third side. Sorry about that bell, guys. So it has a length that is half the length of the third side, and it is parallel to the third side. So these two facts are going to help us complete the next couple of problems. All right, guys, so we have this triangle ABC to the right, and we're going to use that in conjunction with our statements to the left to find our unknown values. So notice that PQ is a midsegment for the triangle ABC. So if PQ is 8, then BC will be 2 times 8, which is 16, based on our midsegment theorem. If BC is 8, then PQ will be 4. Remember, it is half the length of that side, triangle side. Okay, some more difficult ones. Let's look at these a minute. So AP is equal to 12. So if AP is 12, right here, what will the length of PB be? Well, they're congruent, so that means that 12 will be the same measure. And AB, which is the entire portion, will be 12 plus 12. So this 12 plus this 12, which is then 24. All right, so we just got off the ground running, so let's look at some ones where we're going to actually be solving some equations that we come up with. So now we're going to throw into some solving for x in order to find these values. So if BC right here is x plus 9, and 5x is PQ, and PQ is 5x, then what is x? Well, we need to come up with some sort of equation. So we know from the mid-segment triangle theorem that BC is 2 times the length of PQ. So now let's substitute those values in. So we have that x plus 9 is 2 times 5x. So we have x plus 9 is equal to 10x. And if we solve for x, we're going to have 9 is equal to 9x. So x is equal to 1. Well, if x is equal to 1, then we can find the lengths of PQ and BC by substituting this 1 back in. So 1 times 5 is 5, so PQ is 5, and then 1 plus 9 is 10, which these values also match up with our mid-segment theorem, so that's a good way to check as well. All right, next one. So if we look, we have PQ is x plus 12. Okay, and BC is x squared. Uh-oh, we've got a square. That might be screaming some Math 1 material that we have. So we need to come up with an equation. Well, PQ is half the length of x squared. Another way to think about that is 2 times PQ is going to equal BC. So we will have 2 times x plus 12 is equal to BC. All right, so let's distribute and simplify. So we'll have 2x plus 24 is equal to x squared. Now, I know it's been a long time since we've solved for quadratic equations, but let's do it, guys. All right, so when we have a quadratic, we need to get all the x terms to the side and set it equal to 0. So I'm going to subtract over my 2x from both sides. And I'll then have 24 is equal to x squared minus 2x. Next up, I'm going to subtract 24 over, because remember, I want it equal to 0. And bring it up here, and what I'm going to get is that x squared minus 2x minus 24 is equal to 0. Now, this is the point where we factor. We need to find 2 things that multiply to our c value, which is negative 24, and those same 2 things must add to negative 2. So can you think of 2 things that do that? Let's see. Ooh, what about some combination of positive or negative 6 and 4? So if we look at this, if we do negative 6 plus 4, that equals negative 2, and negative 6 times 4 equals 24. So those are our 2 factors. So we'll have x squared minus 6x plus 4x minus 24 is equal to 0. So all I did was rewrite this middle term using our numbers we figured out. I'm going to group my first 2 and group my last 2. Now I can factor out a GCF, which is x, and I'll be left with x minus 6. My GCF over here between 4x and negative 24 is 4. And I'll be left with x minus 6 equals 0. So that's good. We match. So now if I take the x minus 6 as the GCF and factor it out, I'll be left with x minus 6 times x plus 4 is equal to 0. Using Miss Frances' favorite property, the zero product property, since 2 things multiply and equal 0, that means one or both equals 0. So I will have x minus 6 equals 0, which tells me that x is equal to 6. Or I will have x plus 4 is equal to 0, which tells me that x is equal to negative 4. So we have 2 values that x could be. So x could be 6 or negative 4, which then would mean that PQ, when we substitute it back in, would be 18 or 8. And when we substitute in our 6 or our negative 4 in for BC, we would have 36 or 16. All right, guys, so we are done with the notes. So what I need you guys to do, and know it looks like a lot, but it shouldn't take too long, is I need you guys to complete number 1 through 9 on this page, and then 10 through 16 on this page. And then, yes, you are going to work on the homework, so hopefully you will finish the homework in class. So I know it says academic, but you are going to also do the academic on page 23, which finishes up on page 24 with number 10. And yes, I know Miss Frances loading it up on you guys, but these notes should not have taken that long. You are doing the day 6 homework honors as well, all the way through to number 14 on page 25. Work together. You guys can do this. Yes, you may need to factor on some of them. Remember, guys, canvas me if you have any questions, okay? If you do finish all of this, you can go back and work on the odd proofs from the day 5 homework on page 20 and 21 that we did not do. I will be checking to see if your pages 22 through 25 are completed on Monday. And I hope you guys have a fabulous weekend.